Welcome to another podcast. In this episode, we're going to be taking a look at what is called the fundamental theorem of calculus. Now, in many ways, this is the most important result of the semester. Knowing the fundamental theorem of calculus, I'll put right up there with chain rule, being able to do optimization problems, understanding what the definition of the derivative is as the most important concepts of the course. The fundamental theorem of calculus, the theorem basically goes like this. We call it the fundamental theorem of calculus. You'll often see us append a number to it, like FTC1. FTC stands for fundamental theorem calculus, and 1 means this is the version 1 of the theorem. There are at least two versions, maybe 3 depending on who you talk to, but 2 versions of the theorem, both of which are called fundamental theorems, but this is the big one. It says, if you know that f prime of x is equal to f of x, meaning f is an antiderivative, so capital F is the antiderivative of f, then this definite integral that we've introduced in the last couple of videos, remember this is the area under the curve from A to B, the value of that, rather than having to do a Riemann sum, what we can do is take the antiderivative of the function evaluated at B, and then subtract the antiderivative of the function evaluated at A. This is huge. It gives us a way to calculate the integral, which remember is calculating the area under the curve, without actually having to resort to a Riemann sum. So a couple of notational things here. We can also express this sort of notationally as, you know, we've got f of x plus c. This is our general antiderivative. We know that this is equal to the integral of f of x dx, which we call the indefinite integral. I can relate this to sort of, this is specifying things now. So this is the real general side of things. This is the general thing. Now I want to specify things. So the integral from a to b of f of x dx is the definite integral. We have a definite interval in mind. So the definite integral. And this is equal to, these are the antiderivatives. Now there's a different way to do this. So we're going to say that the integral is still f of x. Notice I don't have the plus c here anymore. There's no plus a constant up here anyway because we're specifying what the constant is. And so we want to use this notation. Oftentimes you'll see it, x equal a, x equal b, or simply just f of x evaluated from a to b, where it's understood that these are a to b, and that this is equal to f of b, so you evaluate the antiderivative at the top limit, minus you evaluate the antiderivative at the bottom limit. So this is what the fundamental theorem of calculus provides. It provides us a way to evaluate definite integrals. It provides us a way to find areas under the curve. So this represents the area under the curve f of x between x equal a and x equal b. Rather than resorting to a Riemann sum, all we have to do is compute the antiderivative once and evaluate it twice. So let's do a couple of examples. We stated last time that we were trying to find the integral from a to b of x squared dx. This is the one we did in the previous video, and we did it for 0 to b first. I'm going to do it from a to b in general here. We know that in this case f of x is x squared, and we know its antiderivative via the product rule in reverse, or the power rule in reverse, is x cubed over 3. So according to the fundamental theorem of calculus, I can say the integral of the integral of x squared from a to b is simply that antiderivative x cubed over 3 evaluated at a and b, which is b cubed over 3 minus a cubed over 3. And when a is equal to 0, this gives us the value b cubed over 3, which was that value that we calculated using the pyramid in the previous video. So everything checks out with what we've been doing so far. All right, let's look at another example. So in this particular example, I want to look at the following area. So I want to look at, this is the sine function. So I want to look at the area under one curve of the sine function. So this is pi, and this would be 0. And so this is sine of x. So I want to find the integral from 0 to pi of sine of x dx. Well, if f of x is sine of x, in a previous video in our discussion on antiderivatives, we noted that the antiderivative of sine is negative cosine. So by the fundamental theorem of calculus, this is negative cosine of x, that's the antiderivative, and we're going to evaluate that from 0 to pi. So we get negative cosine of pi. Now you need to be very careful here. It's minus negative cosine of 0. So this is f of pi. This is the antiderivative at pi, minus this is the antiderivative at 0. And those values are cosine at pi is negative 1, so this is negative negative 1, minus cosine of 0 is 1, so it's minus a negative 1. Be very careful with your negatives when you do antiderivatives like this. So this is just 1 plus 1 or 2. And so there's a total area. So the area under that curve is equal to 2. Okay, finally let's do one more example here. Let's look at the function 1 over x. So the graph of 1 over x is one of these that you may not be as familiar with as some of the others in this video. But let's do it this way. The graph of 1 over x does this over here and does this over here. So it's got two parts to it. And suppose I wanted to find the integral between 1 and 2. So I wanted to note the area under the curve. So I wanted to find this area. So this is the function 1 over x, and I wanted to find the area under it between 1 and 2. Well, by the fundamental theorem of calculus, this is the integral from 1 to 2 of 1 over x dx, and if you remember what we said about this one, this is the natural log. So the antiderivative of 1 over x is natural log because the derivative of natural log is 1 over x. And we're going to evaluate that from 1 to 2. So this is the natural log of 2 minus the natural log of 1. And the natural log of 1 is 0. So this area in blue is equal to the value of the natural log function at 2. So it's incredibly important that you understand the fundamentals laid out in this video, what the fundamental theorem of calculus is, what it allows us to do, and how to actually apply it to find definite integrals and their values. All right, thank you for watching.